Hello and welcome to Wally World Model Railroad in a Bedroom. In today's video we will discuss basic DC reverse loop wiring. So simple it's easy. You're at that point where maybe you want out and back operations or just turn and run your loco in the opposite direction on the same track. A reverse loop will provide you with this solution. As you can see, my train is eastbound heading for the return loop. Upon reappearing, the train will be westbound. This is not an automated reverse loop, so the train will need to be paused before proceeding. As I'm at a station, I can justify this action. We started our journey rolling past Smash Palace and onto the city. Then, as you can see, after a pause at the station, we have returned on the same track to roll past Smash Palace yet again. Now let's get started. Step 1. With the aid of a set of points, or turnouts, whatever you like to call them, we can run the track around back on itself. Now this clearly achieves what we want, but at the same time causes a short, as the diagram clearly shows. To overcome this, our reverse loop must be separated from the main line power supply by means of insulated rail joiners. As an alternative, you can cut gaps in the track with a track saw or power tool. All 4 metal rails must be insulated from the main line. Now, here we have a reversible loop wiring diagram for DC systems in its most basic form. Picking up power from the main line prior to the reverse loop and then powering the reverse loop through a double pole, double throw on toggle switch that has been cross-wired. This may be a very basic DC manual reverse loop setup, but it is very cumbersome to use, as I will show you. After that, we'll look at basic options to improve it. For this basic reverse loop setup to operate, you need to 1. Switch the turnout for the direction you want to enter the reverse loop into. 2. Switch the reverse loop toggle switch to match the reverse loop polarity with the main line. 3. Then run your train into the reverse loop completely between the insulated section. 4. Stop your train completely in the insulated section of the reverse loop. 5. Switch the reverse loop toggle switch once again to match the reverse loop and main line polarity. 6. Now switch the turnout points to allow exit from the return loop back onto the main line. 7. Set your power controller into reverse. And finally 8. Run your train back out onto the main line. Well, we now have a manual DC reverse loop system that's easy to wire but cumbersome to operate. Can we do better? Yes, for approximately $50 and only a little extra effort. We can add a tortoise switch machine to operate the turnout. And instead of a double pole switch, use a 4-pole double throw on toggle switch instead. If we break down the wiring in stages, it is still very simple. The 4-pole double throw on switch in reality is just 2 double pole double throw switches joined together. One side of the switch will control our turnout, while the other side will control our reverse loop. There are 8 terminals on the tortoise switch machine. Don't worry, we only have to wire the 2 outer terminals for operation and supply a 9 to 15 volt DC power supply to the circuit as shown. We now have a manual DC reverse loop that's easy to operate. Let's look at the full wiring circuit and its simple operation. With this new feature, when we enter the reverse loop, the rail polarity will automatically be configured with the main line. Stop the train in the reverse loop once it's fully inside the insulated section. At this point, put your controller in reverse. Now set the turnout switch to allow exit back onto the main line and proceed. If you have used 2 turnouts to create a reverse loop, the same as my layout, one toggle switch will control both the turnout and polarity, while the other toggle switch will only control turnout. With this configuration, I am only changing the polarity of the reverse loop, not the main line. So the train leaving the reverse loop section onto the main line is going forward, but the controller is set in reverse due to the polarity change. Another reverse loop polarity switch can be added to the main line if you wish, in which case it is not necessary to stop the train or put it in reverse. Just throw the second switch while train is in the reverse loop section and carry on. I prefer not to use this option, as all other trains on the main line must be put in reverse to run forwards. I can have several trains on my main line at the same time. Any train running on my main line will suddenly find itself reversing. A simple control panel will make operations easy. This is one of 4 control panels on my layout. On the left side, lines B and B dogleg around the room and join each other. The same goes for A and A tracks on the right side. Mainline and reverse loop operations are controlled from this panel, as well as the main passing sidings. DC trains can also be held in 5 main sections. Here we have reverse loop operations on the control panel. Lower turnout switch at base of reverse loop is set to main line, as the green LED indicates. Train rolls past turnout and on past AA towards the 4-pole double throw switch at the top of the reverse loop. Orange LED indicates turnout set to enter reverse loop and polarity correct. Train enters return loop and stops. Turn the power control in reverse at this stage. The 4-pole double throw switch is then turned back to main line and reverts polarity in doing so. Green LED shows action. The double pole double throw switch at the base of the reverse loop is now operated to allow the train to exit onto the main line. The orange LED indicates this operation. Indicator warning lights on the control panel are easy to wire as well. Just one more step at a time. An LED, a resistor, LED holder and some wire will get the job done. The following short description will help you understand an LED better. Back to our wiring diagram again. You can see a little extra wiring. This can be added anywhere between the 2 wires from the toggle switch to the tortoise switch machine, wherever is most convenient. Once set up, a quick glance at your control panel will indicate turnout direction. LEDs come in a range of colours. I prefer to use green to show turnout direction, but in the case of reverse loops, I prefer orange. You may have noticed on my control panel, I have both DC and DCC operations to operate on my layout. The on-off-on switch simply toggles from DC controller to DCC bus power supply. This gets a little more complicated when it comes to reverse loops though, as different setups are used. With the aid of, yes, a little more wiring, we can solve this problem too. But before we do that, I will just run through a little soldering 101 and at the same time make a reverse loops toggle switch. As your model railway grows, wiring will play a big part. The sooner you get yourself a soldering iron, side cutters and wire strippers, the better. Soldering is very easy with just a little practice. Before soldering, always heat the iron, dip it in flux, clean and brass wire and tin tip with solder. Start with this golden rule and you're on your way to mastering great soldered joints. Now that your tip is properly tinned, you can start soldering. Try to solder immediately after tinning the tip. The sooner the better. While you're working, clean and retin the tip regularly. Tinning improves conductivity and makes soldering easier, as well as quicker, which is a good thing. Here we have a completed reverse loop switch. Toggling it from one way to the other reverses the polarity. Now to construct a reverse loop switch, first we'll take the power wire and a short, approximately 2-inch long piece of wire, twist the two together, add some flux and tin the end. We will carry out the procedure on the other end of the short wire as well. First some flux, and then tin that end as well. This will make joining the wire a lot easier when we connect it to the switch. Now take the double pole switch and we're going to add flux to all the terminals on the switch as well. Just a little bit is all that is needed. Once we have done that, we'll then take the soldering iron again and tin all the terminals. And once this is complete, we'll be ready to start joining the wires in sequence. As you can see, I've already soldered the red wires on diagonally just to speed things up, and now I'm soldering on the black wires. Again, as you can see, I'm just going to solder them on diagonally. Pre-tinning makes everything so quick and easy. Here we have the switch, black wires diagonally, red wires diagonally. Now here we have a completed double pole double throw switch, as you can see, and also the completed 4-pole double throw switch. Finally, I will touch on DCC reverse loops. A simple cheap option in my opinion is the Digitrax AR1 reverse loop controller. These DC and DCC reverse loop systems are simple but not compatible. The trusty old double pole double throw toggle switch and a little more wiring will help us out yet again. Install another double pole double throw toggle switch A between our reverse loop system and its power supply from the main line. This will effectively allow us to switch from DC to DCC reverse loop systems isolating one from the other. Now wire from the other side of the new toggle switch B to the isolated section of the reverse loop via the digitracks as shown. We now have two independent reverse loop systems operating on the same layout with the flick of a switch. I hope this video has been helpful to some of you. The ideas and processes that I have shown on this video work well for me on my layout, and I hope they will work well for you too. Thank you for watching.